Hey everyone, how's it going? Andrew Robinson here. Just wanted to make this quick video, well not quick, but wanted to make this video for kind of both documentation purposes and for some of my friends, and then I guess since this is ultimately going to get put up on YouTube, just for anyone really to watch and get some good information out of this. So I know this isn't normally the type of videos I would be doing. I normally try to kind of stick with the hobby side, not my professional work side, but I figured this will be some good documentation and a lot of people will probably get some use out of it. So I've been playing around with a few Ubuntu servers recently, and I've decided to move one of my servers that has been in production for a little while now out of this location where I am right now and move it down the road about 45 minutes to one of my backup locations. And because of that, I wanted to kind of increase some of the availability and redundancy of that system. Because if for some reason if that system goes down, I don't want to have to drive 30 to 45 minutes to get over to the system and be able to do some repairs. So what I thought I would look into is going ahead and getting some redundant interface configurations done, and some redundant topologies, power, different things like that before I took it over and implemented it. So while I was coming up with different ideas of how I wanted to do that, I started thinking about link aggregation and thought, hey, it would be a cool idea to, or it's a cool idea to make a video for some of my friends that could find this information useful. So ultimately that's the reason why I'm doing this. But so essentially what I set up here was basically just a demonstration of how you can use link aggregation between a Ubuntu, in this case a Ubuntu 10.04 LTS server. This is running off a Dell PowerEdge 750, which are the basically all the servers that I use. And this is hooked up to a Cisco Catalyst 2950 for this demonstration, but as we'll talk about later, you can pretty much use any access layer Cisco switch for this purpose. So anyways, just wanted to again basically show you the configuration of this and how to get this done. So let's go ahead and jump into some of the actual command line for the Linux box and for the Cisco device, and we'll actually show you how to configure this stuff. So to start off, let me go ahead and get logged into Linux just so that this doesn't time out on us. So the login that I chose, not that it matters, is just Andrew for the login and Andrew for the password as well. So before we get officially started with the Linux configuration, just a few things that I wanted to mention. The first is just a general disclaimer to both my friends and to anyone that may be watching this on YouTube. I would assume that if you have enough knowledge of this stuff to be wanting to implement this type of a configuration, you probably have enough common sense in IT to know to not roll out something like this in a production environment. So please test it, do it in a lab, do it on a bench server, switch, whatever you've got laying around. Test it, get everything working, get the configs written and the procedures written to do this, and then roll it out to production. I don't want you guys bringing down servers and then for those of you who know me personally, I don't want to be getting nasty phone calls. So anyways, the other thing that I wanted to mention is just kind of the prerequisite knowledge. By going through this video, I'm assuming that you have a pretty good knowledge of the Linux operating system, including some of the commands that we're going to use here, also some of the files that we're going to be editing within the file system in order to make these configurations. And then for CCNA knowledge, or for Cisco knowledge, I would assume that you have a pretty good, solid CCNA foundation, because some of the concepts that we're going to be talking about, while they are covered in the CCNA, they're starting to get right on the edges of the CCNA topics. So make sure you're really comfortable with Cisco as well, because we're going to be blowing through commands, and I'm going to do my best to make sure that I'm explaining each one as we go. But I may kind of whiz by something accidentally, just not thinking much of it, because again, this is not complex, but slightly higher level configuration than what most people are used to. So there are going to be a few added steps, and I shouldn't have to explain everything. So I shouldn't have to explain entering into global configuration mode on a Cisco device, or using Nano or VI to get into a file to perform some edits. So anyways, so with that said, let's go ahead and jump into some of the configuration of this Linux host. So to get us started, first let me mention that this server, the PowerEdge 750 that you saw just a minute ago, we're assuming that this is 100% blank. So this is a brand new installation of Ubuntu 10.04. And so we're going to have to do some kind of initial configuration, some basic configuration, just as you'd have to do with really any box. So the first thing that we want to do is, let's just do a sudo-s. Clear off our screen. And let's do an apt-get update. So essentially what we need to do, I guess at this point, we're going to end up pulling down a package that we're going to use in order to create the logical, I guess, ether, if you want to call it an ether channel, so we can actually do the link aggregation. So we just want to make sure that everything is updated, and we're also going to do an apt-get upgrade. Yes. So while that's going, we'll just talk briefly. We want to make sure that all of the packages, or everything in the repository is well, everything on our local system is up to date, so that we can actually get the package. And the reason why we need to do this is, when I first tested this a little while ago, I noticed that when I was looking for the package, it wasn't showing up in the repositories, or it was saying it couldn't find it. So it's pretty critical that you do this first, otherwise you're going to run into the same situation. So let's let this run for a second. Hopefully it shouldn't take too long, but I'm going to go ahead and, well, it's going pretty quickly. Okay, so I went ahead and I paused the video earlier. It was just taking a really long time. It actually took several minutes, so I'm glad I did. I guess I was a little further behind than I realized. But now that we are unpaused, and now that everything is done, I've got the screen cleared, clean terminal, we're ready to go. So let's get started now with talking about some of the different interfaces that we're going to be using. Now, through the magic of editing, I've got a nice little table and a topology that you can see now that shows some of the different interfaces, networks, all the goodies that you're going to want to know about for this. So very simple setup. Basically, we're just piggybacking off my production network. I've set up a subnet for this, so we're actually using a 1077.10.0/24 network. So obviously we're using .1 as our gateway, 255 as our broadcast. And in terms of addresses, which is the important part for this, we're going to be using 230 as Ethernet 0 on this Linux box. Now, even though it technically doesn't matter, because these physical IP addresses are going to go away when we create the logical one, we're going to consider Ethernet 1, which we're going to technically configure here in a minute, to be IP address 231, and then our virtual IP that we're going to create is going to be 232, and then finally, when we get into our Cisco configuration side, we're going to use 233 as our Cisco IP address. Now, keep in mind, we are using a layer 2 switch, so we are using an IP address for it. Just remember, that's just a management IP address that's assigned to The interface VLAN 1 in this case is what we're going to be using, just because this is a simple setup just for kind of demonstration purposes. So again, really simple topology. Basically the server is just hooked straight up to the switch. Switch piggybacks off production network, and that's pretty much it. I've got this the terminal that I'm using right now, basically off the same switch pretty much. Let's pause for a second. What I actually meant to say was this terminal is not directly connected to the catalyst switch that we're configuring. It's actually connected to a switch out in the production network that you can't see in this diagram. What's just important to realize is it's in the same layer 2 topology, so we're just using it. It's off to the side, and we are still able to connect up to the switch and up to the server via SSH. So unpause. And we're going to look at all that here in a second when we get into the Cisco device. So let's go ahead and start by taking a look at some of the interfaces. So on our Linux box, let's go ahead and just do an IF config. And you can see here, just like we were talking a second ago, we've got ETH0, and you'll notice we don't have an ETH1. That's just because when we set this up initially, when I did the install on this box, I only configured a single interface on this. So again, 230, you can see all the information there. And if we do a sudo nano etc network interface, we can pull up the configuration file for all the network interfaces. So we're going to come back to this here in a second. The next thing that we need to do, now that we've updated all of our repositories and everything, we're up to date with the server, let's go ahead and pull down one of the packages that we're going to need in order to create this logical grouping of physical interfaces. So let's do that now. What we're going to need is a package called EFENSLAVE. Ifenslave, I guess is how you would pronounce that. So let's do a sudo apt-get install ifenslave. So it's going to go ahead and find it and get all of that pulled down and installed, and that's all we needed. So let's go ahead and clear, and we're going to go back into our configuration file now. And we're going to start to do some configuration in here. So the first thing that we want to add into this configuration file is actually our Ethernet 1 interface. So let's do an auto ETH1 interface ETH1 inet, and we're going to set this to manual. Now, as far as why we're going to do the configurations we're going to do, I'm going to explain here in a minute. I'm going to do a bond master bond 0, and then we're actually going to come up to here, and we're going to just start deleting some of these lines. So delete, 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 delete. We're going to add in bond master. Do a bond 0 again, and then we're going to change this over to manual as well. Okay, let's put a space in there. So now we have ETH0, iFace ETH0 inet manual with a bond master bond 0, and then we have ETH1 with essentially the same thing. So Ethernet 1 inet set to manual bond 0. So this is essentially us taking those two physical interfaces, and we're basically associating them with the logical interface that we're getting ready to configure. Now, the only other thing that we got to configure in here is obviously the logical interface, and this one has a little bit more configuration. So what I'm just going to do is, I already have this pre-written off screen. I'm going to go ahead and just paste that in, and we'll just explain it. That way you don't have to just sit here and listen to me type. So we've got auto bond 0, interface bond 0 set to static, and oops, and I gave it the wrong address. Okay, so we've got, again, we were creating that logical address, and we're giving it, as I said, we're using 230 for Ethernet 0, 231 for Ethernet 1, and so I'm just doing the next logical increment. So we'll do 232 as our essentially our virtual IP address. So I want to pause one more time just to clarify a little bit. I think I might be confusing some people because I keep mentioning the fact that Ethernet 0 and Ethernet 1 must have IP addresses. That's not true. They're actually not going to have IP addresses. The only interface that'll have an IP address is the virtual interface. The only reason why I was just referencing those is I wanted you to see that if you had a server that already had IP addresses configured on the physical interfaces and you transitioned it to a virtual, I wanted you to see the difference between the physical configuration for the physical interfaces and then the logical configuration of the logical interface. So that's the only difference. So don't stress, you will not have IP addresses configured on the physical interfaces. So you don't have to increment like that. You could do 230 or whatever IP address you want to use as your virtual interface, and then you could have another server that uses the very next IP address, like say 231 as its virtual IP address. So this was just for the sake of showing how you would go from something, again, that already has configured interfaces to changing over to a virtual interface. So unpause again. Now this is the important part right here. We've got the bond mode set to 802.3 AD. Now, for those of you that have a lot of Cisco experience, you know that Cisco can do several different types of, or can use several different types of link aggregation protocols. It can use the Cisco proprietary version, which I forget exactly what the acronym is. It's like PAGP, I think, something like that. Which is really only used, going back and forth between Cisco devices. And then there's also the IEEE standard, which is the LACP, which is Link Aggregation Control Protocol, which is essentially 802.3 AD, essentially. So we want to use that because, again, we're going from a Cisco device to a server. So you're always going to use LACP between Cisco devices and servers. So we've got that set. Everything in here should be configured correctly. So at this point, let's just make sure we don't have any additional spaces or anything. I don't think that's critical in this configuration file, but I always just like to double check just to make sure. So, and we'll just look over, make sure we've got everything set correctly. So, since I had an improper IP address there a second ago. So that's essentially how you want everything to look. So we're going to go ahead and save that and close out of that configuration file, and we'll move on to the next step. So our next step really is to just move right into the Cisco device. Unless I'm missing something, which I don't believe I am, that is all the configuration that we need to set on the Linux device. Now, one thing that I should mention, I'd recommend, unless you have multiple interfaces, I would recommend doing it in this order, because what we're going to do next here is just go ahead and reboot the server, and we're essentially going to lose SSH connectivity. Oh, and I guess I should have mentioned that as well. When we started this video, again, this goes back to me assuming that you have kind of prior knowledge. Both the switch and the Linux server had been set up with SSH, with proper credentials and everything, so I'm actually doing this remotely from a terminal. But when we go ahead and we do reboot the server, now that we've essentially shut down those physical interfaces and they no longer have IP addresses associated with them, and the server is essentially listening for the switch to communicate using this using the LACP protocol. Until we configure the switch, we're not going to have connectivity. So bottom line, configure the server first, because you're going to use the switch to get to the server via SSH. Reboot the server, then let's back up a step and work on the switch. So at this point, let's go ahead and let's go ahead and reboot the server, and we will go ahead and move on to the Cisco Catalyst 2950. Okay, so we've got the Cisco switch now up and ready to log in, so let's go ahead and get logged in. Again, I use the same thing. So AAA is enabled on the switch with SSH just to allow us to use local usernames, use the local database within the switch. So again, we're using Andrew as the username and Andrew as the password. That will give us user privileges on the switch. Let's go ahead and do an enable command. Again, Andrew is the enable secret to get us into privilege exec mode. And let's just go ahead and freeze right here for a second and talk about the switch a little bit. So we're using a Cisco Catalyst 2950. You can pretty much use probably any access layer Cisco Catalyst that is going to support exactly what we're trying to do here. So you can use a 2960, 3000 or higher. I don't imagine why you would be using something higher than this. Maybe you have a larger distribution layer switch in a wiring closet somewhere and you're hooking your servers directly up to that. Who knows? But all of them should support this protocol. Now, with that being said, let me show you something. Let's do a show version. Right now on this switch, I am running this iOS or this image. Now, prior to doing this video, I had to actually upgrade to this version, not only for the sake of SSH, but I noticed that when I was trying to do some of the link aggregation configurations, that it didn't have, there were only like 3 or 4 different configuration options that I had available, and they are all the Cisco proprietary. So it didn't have the ability, even though the protocol said it was there, it didn't have the ability to officially negotiate LACP communications. So I went ahead and I actually tested it on, or I looked it up on another switch that's actually running in one of my production networks, and that I know is running this image. And I tested the commands on there, and everything was present. So I just went ahead and reflashed the switch, got it up to this version with this image, and everything is working fine now. Now this also gives me, like I said, the ability to do SSH, whereas before I was having to just use Telnet, so which is icky, but not that it really matters all that much since this is just a demonstration. But anyways, so just so you know, if you run into issues when you're trying to configure link aggregation and it's not, some of the commands are missing, do a show version, see what image you're running, and as painful as it apparently is to some people, just suck it up and reflash the switch and your problem should be fixed. So from here, let's go ahead and take a look at some of the different interfaces on the switch. So I have this configured, very simply. If we do a show IP interface brief, you'll see that as of right now, I went ahead and I shut down every port except for the ports that we're going to be using just for the sake of this demonstration. So we've got Fast Ethernet 1 that's up. That's our uplink from the production network. I also have 17 and 18. Don't ask me why I used 17 and 18. I think they were just convenient in terms of where the how the cable's bent coming out of the server. Anyways, and the only other interface that we have up, again, this is a layer 2 switch, so we're able to assign a single IP address to a single VLAN and turn that VLAN up as a L3 interface. So we do have VLAN 1. Again, I know this is demonstration purposes, but we have VLAN 1 turned up right now with a management IP address, as we said in our table 107710.233, which is giving us management via SSH. So let's also take a look. If we do a show ether channel, you'll see that right now we don't have any channel groups set up. I'm trying to think if there's anything else. I guess we can also... Well, I think that pretty much sums up everything that we need to cover before we get into the actual configuration. Again, everything is pretty much just operating in VLAN 1, I believe. Show VLAN brief. Yeah, so it looks like some other VLANs got pulled over from whenever whoever we purchased this switch from. We didn't delete the VLAN.dat file, but anyways, so yeah, so everything's operating in VLAN 1. Demonstration purposes, let's go ahead and jump into our configuration now. So what we're going to want to do to get started is, of course, enter into global configuration mode, so configure T. And then we're going to want to enter into the interfaces that we want to configure. So in this case, we're configuring interfaces 17 and 18. So I'm going to do an interface range FA0/17 to 18 to enter into both of those interfaces. Now, it should be self-explanatory that you're going to be configuring the interfaces that you're going to be using. So let's say you have 3 servers, each with 2 Ethernet ports, and you're going to use ports 1, 2, 3, 4, 5, 6, then obviously you need to configure those interfaces. You know, it doesn't have to be in an order. You could technically space them out across the entire switch, you know, choose 1 and 7 or 4 and 2, and you know, I don't know why you would want to do that in terms of cable management, but just know that you need to configure the interfaces and put them in the right group for, you know, however you're going to actually set this up with your network. So the other thing that I wanted to mention about, you know, setting up with link aggregation, in this configuration we're only doing 2 interfaces because that PowerEdge 750 that we're actually going to use in this demonstration, or that we are using in this demonstration, only has 2 gigabit interfaces on it. Technically, and I'm not sure, you'll have to look up the limitations. I know for Ether channel with the Cisco proprietary version, it has a maximum of 8 interfaces in a channel. And I'm not sure what the Linux limitations are, or what the limitations of LACP are. You'll just have to, you know, take a look at what the specs are for that. But there's nothing that says you have to use 2 interfaces. You could use 3 or 4 or 8 or, you know, whatever the max is. And remember, it's not just redundancy that you're getting out of this. You're also getting increased bandwidth. So in the case of, you know, us using 2 interfaces here, on a 10100 switch, of course, we're essentially doubling our bandwidth to, you know, double that of what the line speed of that port is. So, you know, theoretical line speed, of course. So anyways, so let's jump into the actual configuration. So we are in the interface configuration for ports 17 and 18. So let's do a channel group. And I'm just going to call this channel group 1. We're just going to assume that this is the first of maybe several servers. And we're going to do a mode. And let's actually bring up the list of the modes that you can do here. So we've got active, auto, desirable, on, and passive. For our case, we're going to use active because, again, we're going to be using LACP to communicate between this Cisco device and the Linux server, or just, you know, any server in general. So I'm going to go ahead and say active. We'll hit enter, and it'll tell us that it's creating a port channel interface, port channel 1. So if we go ahead and type in end to drop back to privilege exec mode and do a show IP interface brief again, we're going to see now that we have a port channel 1, which is in the up state. So at this point, for the most part, unless I'm missing something, all of our configuration should be done. So let's go ahead and take a look over at our Linux box now. Let's just make sure we haven't missed anything. In fact, before we leave the Cisco terminal, let's go ahead and just try something. Let's do a ping 10.77.10.232, and you'll see we get a 100% success. However, if we try to ping 10.77.10.231, it's going to fail, as will 10.77.10.230. So essentially what we've proven here is the Linux host is now utilizing that virtual IP address, the 232, and it has essentially completely shut down, or we've, by us, unconfiguring those addresses, it's not using those addresses anymore. So let's go ahead and we'll just take a look over at the Linux box real quick, and then we'll actually take a look at the actual physical cabling, and I'll just show you the failover real quick. So again, here we are back on the Linux host, and you can't tell, but when I SSH'd into the Linux host this time, instead of using one of the old physical IP addresses for the physical interfaces, I'm now using the virtual IP address. Let's type in Andrew again, Andrew for the password, and you can now see IP address for bond 0. We're utilizing 10.77.10.232. And if we do a ping and source that IP address, 10.77.10.232, and let's just ping one of Google's servers, we're now able to ping out across that, again sourcing that virtual IP address. So let me pause this video, and I'm going to actually get the camera back out, and we'll go back out to the table and actually take a look at the physical interfaces and the failover. So here we go. Okay, so here we are back out at the switch and the server so that we can show exactly what it is that we just configured. So as you can see, I've got a ping running on the server just up to one of Google's DNS servers. I've got it pinging 8.8.8.8, and if we go ahead and unplug one of these, bam, you'll see that we don't lose any connection whatsoever. And if we plug it back in, the link come active again, and pull the other side, bam, we still don't lose connection. So you could essentially have 8 of these virtual links, or again, whatever the max supported is, and you could lose a physical link. Someone could cut it, someone could disable that port, and your server is not going to go down. So that's pretty much it, guys. I hope you like this. I hope that you guys will find this useful, and you'll be able to apply it to some of the systems that you already have. Remember, it doesn't just have to be a Linux host in order to do this. You can use the Cisco configuration side of this video and configure LACP with say a Windows computer. I've never actually done it. I've done it with LAN teaming, and some of that was, the way it was handled was kind of funky, so maybe I'll do another video showing how to do redundant connections up to a Catalyst with a Windows host. So that's pretty much all there is to it. Let me know what you guys think. I'll talk to you later.